And next month, I believe, is Dave Klein and Docker, if I remember correctly. So let's figure out how we can get some more chairs into here. I guess let's see if we can move this table back a little bit. And then we actually, before Juan speaks, bring some chairs in and sit here. So one, we can have a fire hazard light breaking there. But I can absolutely put a couple chairs here, not in front of this camera, but I can probably fit another chair or two in here. What we may want to do is, since I only have one person on the computer here, is move him over to this table, take down that chair or that table, and then we can fit in probably another 3 or 4 people. Okay, so take a minute to reorganize these. Someone use their special spatial relations to see what we can do. Like I said, I think we can get by with just, we take out this table and move the laptop over here. That will definitely.
Are we going to try to get the project on? I can't see it on. No.
I like this 5 process. I also like it because I can take the space off, and it's also makes it more safe from this room.
What's that?
I dropped it right before I luckily we avoided that. The metal got a little chip here, a little sharp. Yeah, I was going to say where he was saying you got it. Put another row of chairs. I like it. We also have where I work. It's kind of a lot of hospital if you're familiar. I'm not really on that north side. Unfortunately, a couple of times, our buildings are dead space.
Space into SPN, that's a really good book.
I have, yeah. And growing up, when I had a outside, Sprint didn't work at all. AT&T was iffy. I used to have an antenna from my phone. Verizon was tower. Early. Not so good. They're not as good as AT&T in this area. I'd like to start TMobile.
Which streaming method are you using?
Sorry?
Which streaming method?
Hangouts, we're doing what the live hangouts?
Okay, you're not actually telling it to store? I'm
sorry?
Are you telling it to store or not?
It will eventually go on YouTube, yes. So automatically put that on YouTube.
Rock, paper, scissors.
That defines how much.
Yeah, this is absolutely possible. So, but again, I will stop it if you're not comfortable.
What was the template? Long ago, I used to buy ages ago. I'm getting just new. I was writing stories about it.
Okay, yeah, no, I'm Boeing. We fly their constellation. So, yeah. So there's actually new models that are coming out. A lot of those smaller things push data for broadband access.
So one other thing I was going to mention, if anyone is interested in open source prosthetics, we're starting up a group in NovaLabs and having our first actual physical meeting here at 2 o'clock. We've already got 2 kids lined up who will be building hands for them. So if you're interested in especially the 3D printing parts of that, that should be really interesting.
Yes, I'll find it.
You guys are too quiet.
Well, somebody was going to talk about, yeah. Sure, go for it.
And so, I guess
as an introduction, my name is Juan. This is my first time here, and I was actually recommended this group from a friend who lives in Portland, Oregon, who's assistant administrator at Barclays. Believe it or not. I don't know how he's connected, I've got to ask him, but that's how I got in touch with Greg. I work for AOL and talent acquisition team, and I support technical operations. And a goal of mine is to really get involved in the community, especially Linux community, because that's where a Linux heavy environment. So my goal here is threefold. Number one, to let everybody know about what AOL is doing from a technology standpoint, hiring, what's open. And number two, to be a fly on the wall and learn, just listen, start to get involved in some of these communities. And three, I also can be a resource for anybody who have a pretty long career in consulting as it comes to human capital and talent acquisition. So if anybody needs help with putting a resume together or interviewing or anything of that nature, I want to make myself available as a resource also. So from a position standpoint right now, it's funny that Greg mentioned that to piggyback off of what he said, we are building a DevOps culture also at AOL and scaling pretty rapidly. Pocket Chef, those are all obviously automation software that we utilize. But right now, our most important positions are our site reliability team needs support. We have a senior network engineer position, and we have several senior system administrator positions and DevOps positions. So if anybody's interested, or if you know anybody, I'm going to leave some cards up front. Feel free to come up to me, and we can discuss the positions in more detail. I don't want to take up a lot of your time here.
Do you use the internet job boards to recruit? The keyword searches on DICE and Monster?
So I do some Boolean searches on there. The majority of times what I'm doing is to seek passive job seekers. Is I do Google X-ray searches, post searches. I do more in-depth searches, find people on their blogs. That's a more effective way to recruit for me and to be involved in the community. Also, engineers are hiring engineers, so getting my team involved and going out to networking events like this, that's how I do the majority of my recruiting. So to answer your question, yes, I utilize every channel that I can, but not as much. I would still recommend that from a job seeker standpoint that it is a resource for you. Mm-hmm. That's what you're asking or what you're trying to get at. Any other questions? Good, so at least the cards up here. And please feel free to get in touch with me about if you have any questions about anything. Thank you.
I guess it's up to me, unless you have something.
Yeah.
Hi, my name is Andrew Whitcomb. I'm with Infinitely Online Services. We're a data center and managed services provider with 15 point presences across the country. Our main offices are in Herndon, right off of 28. We're currently filling, I didn't prepare anything, so it's off the top of my head, for 3 technical positions. One is a technical account manager to supervise customer accounts with managed services contracts, primarily coordinating work to be done and communicating with customers about them. Another is a provisioning engineer to provision services for new customers or customers with new services for colo networking services, managed support contracts. And the third is an overnight help desk / junior system administrator position, shifts something like 7 p.m. to 3 a.m. or 3 a.m. to 11 a.m. Great for a student who's balancing work. So if you have a protege or yourself or a nephew or something, come see me and I'll give you a card. You can Google just info relay careers for everything there. Thanks.
You're on. Good deal. Hi, my name is Joe Klein. I've been in this field for years and years and years and years, and some of us also still have gray hair. Mine's hidden really well. Come on, folks. Actually, my first Linux box or Unix box was 1981 Fortune. I remember that long build Fortune 68,000 for terminal. Yes. So I started a Unix users group in Jacksonville, Florida. We're talking, 4 people that showed up. So it was pretty entertaining. So I've been part of that community, and it's funny because I kept on getting asked to go to the security side because we get on something and go, we're not sure what this is. And I look and go, well, somebody just tried to hack the password or whatever. And actually that's where I got into the field, was that I was doing a project for school, and they said, knock my socks off. And this guy hadn't done a really good job, so I enumerated passwords and got it to a 3D. So then I became the administrator. I did get an A in the course, but I became the administrator for the course. I have spoken at lots of different conferences, security, Linux courses, Linux classes, Unix World. If you remember the old Unix World, I helped write articles and stuff like that. So I've been doing this forever. My current project is that I got funded by the state of Virginia to start a cybersecurity business. I've been in the security business as part of this because, again, the guy that likes to break stuff is usually the guy who's in the security business. I like breaking stuff. So I've ended up starting a company called Disrupt6. We're actually focused on a big gap in the market, which is there's no IPv6 only products right now. And we'll talk about that as we go on. The IPv6 only products are the ones that are really good at detecting vulnerabilities. Just don't exist. Why? Because I help write the standards and a lot of the different the government agencies and things like that. I got to do testing, and the products fall over. So it's a big concern right now. So I got funded to do that. Today we're going to talk about IPv6 security for Linux, and yes, at the end, I'm actually a startup, and I'm looking for a couple people too. So I'll talk about that when I get there. I need to screen. I have this everything else. So how many of you are running IPv4? Now, how many? Now, put your hand down if you're not running IPv6. Okay, so yeah, most.
Remember those negatives there,
Well, it's funny because most networks that I've done pen testing over the last 15 years on typically have IPv6 enabled on the link local, on the local segment. If anybody's involved in the Microsoft community, you probably know that the current version of Exchange only does IPv6. If you turn it off, it breaks other things. So that's a problem, and a lot of the Microsoft-owned products are going to IPv6 only. So there's this real big push and this need for this technology. Just waiting for my slides.
Sorry, do you just have a normal presentation in like a PowerPoint or something?
Yeah, I got a PowerPoint.
I can snag it on from mine if you want to.
I guess I don't have USB, so I don't trust them.
Well, I do have a USB with me, but if you want to do that.
So, yeah, I don't have USB. Only thing I have is a laptop and a laser. These lasers are cool.
The wireless.
I need to check the walls and
So I get to point at you every time you get press.
I guess I can do that.
Yeah.
I need another loop if you can get me that over there. Something. No, I'm fine.
As far as roles, sysadmins primarily, DevOps, security people. I'm not going to talk a lot about that. Sorry. A little bit, just slightly. Think about it, watching other vendors fix stuff. So, like I said, I decided to create my own products because they. Okay. Let's see.
Someday we will be complicated.
Oh yeah, that's the big thing I've been doing for the last 3 or 4 years is hacking Internet of Things. There's a big push. I've broken cars, I've broken boats, I've broken pipelines that work in houses and buildings and health control systems and things like that. So it's pretty damn entertaining. Mostly because the vendors give you the same, comment. It can't be a problem.
Famous last words.
It's funny, you have to prove it every time, right?
Yeah, they want you to prove it. Nowadays, they call that they want you to prove it for free, and then spend your time, and then they provide you a bounty of, barely compensating you for work. Yeah, it's interesting.
Let's see if I can get that. I think that's quite
Like
clear.
SDR.
I did it for a couple years ago when I was renting cars, because a lot of the cars, the controllers,
Right.
force,
Right.
are really fun because a lot of them have replay attacks. And it got a little bit touchy when some researchers broke the wireless on Volkswagen. Volkswagen sued them for reverse engineering their proprietary protocol, which was bad enough that they were able to reverse it. You don't have the Judo either. Oh, there you go.
Yeah, that's a while. You have to switch the lines over.
Yeah, but I think I can see something out there, but I need to see something out here too.
Oh, there it goes. Almost. I don't see any light at all.
That's my
Oh, there it
problem.
goes. There it goes. It's warming up.
You should see something on my desktop.
The word scales is next to it.
So anybody's really interested? Yay. Anybody's really,
Yeah, look at that.
anybody's really interested?
So
in
is
this
anyone able to kill the lights? Because otherwise we can't see much.
There's a light switch right outside the door.
That should be the one for the room.
So anybody that's interested in this topic, hardcore, there's a conference I'll be speaking at in 3 weeks in Denver. The IPv6 Task Force.
You're the first one I've ever gotten a presentation for in white screen already.
I went white screen only because of the,
Yay.
okay. So like I said, I've been speaking this topic, part of this community, part of the, let's see, I sit on the CIO IPv6 Council for the US government and the North America and the World IPv6 Forum. I'm actually waiting for the okay to go to Switzerland, Geneva in November, where I'll be speaking on new attacks against IPv6, which is funny. So they give me vouchers to go to speak globally about it. So it's pretty funny.
No one found a light switch? I guess
No,
not.
it's remote and remote.
Well, someone turned it on when we got here, I thought.
Yeah.
The remote control light switch turned into a remote control igniter.
Yeah. So you guys figured out something?
I'm doing
right
it.
here, but I'd actually prefer plugging it here because I can control it. I don't have to go like this every time.
No, that's fine, yeah, but if you guys can get it to work out there, go ahead.
So the question is, do you have that converted?
No, I do not.
Okay. So all you have is Lightning, you don't have anything
I love it.
original only? That's the only Lightning which looks just like that, so that's probably not going to work.
Bastards!
Shit.
I can sneak that little point out there in corner.
I mean, I want to put the laser edge here every time.
I do have a remote if you want that. Do you want a remote so you can do it yourself?
Yep, I'll just put it in, it's more fun.
Yeah, that's fine. It even has a laser in it.
Okay. So there's my contact information. Okay. So this is the man that created the protocol that has ensured that we all have very good jobs.
So before you go on, who here was at the mid-service talk for NovaLug? Come on, I was the only guy who made it? Wow, I'm very disappointed. So we had Jake come and speak at NovaLug.
Yeah, great guy.
Absolutely. He talked about he was setting up, at that point he was building IP to Mars, TCP IP to Mars. There was a problem with latency he was working on, but it was a great talk.
Yeah, they're actually using SDN, or not SDN, they're using, I forget the protocol. I worked on it about 4 years ago because it had some security and some other issues. So, so this is the guy that actually created the protocol.
Also visited this building.
You did?
Cool. At a NovaLug.
Yeah, he's really involved in the community. Now that he's with Google, he's been told to outreach. I spend time with him all the time. I'm part of his IPv6 task force. So he and another guy, Jim Bound, came to me and said, Joe, you're evil. Because I was going to different conferences and I'm sitting down and having dinner with him. I go, ooh, we could hack that by doing this. This would be really interesting. And they got tired of it after a beer or two. Anyway, we challenge you to try to fix this stuff. So I said, okay, I accept this challenge. That was 14 years ago, and I'm still doing this. What the hell? So, so he made a couple assumptions. Okay, first he said, you know something? This is a demo system, because demo systems never go into production, right? So we only need 4 billion devices. So that's good. It fit in the address space at the time. Also, that all systems would be secure by default. Come on, this is where the humor comes in. Okay, and then all systems, networks, routers, things like that would be trusted during the demo phase of his project. And as he said, it got out of the lab. Okay, there you go. So we basically said, yeah, I underestimated the popularity of the internet, is what he told me a few weeks ago. So IPv6 was actually born to try to fix that problem. It was a re-engineering based on other network protocols to add other features to it. And again, this was a protocol that was talked about in the late 60s, was finally funded in the 70s, developed in the 70s. V4. So it took a long time to bring it to fruition before, so from 70 to 80, or excuse me, to 90 before it actually got released to the commercial space. So it's a long time. Clip. Okay, so now that all the marketing geeks are really excited because now we're going to have more addresses, 4 billion is not enough. Now we have to have 360 undecillion addresses. Yes. So, this is where we worked, which is our IT, and now all these other devices have IP addresses on them. Many times not secure, many times not supporting IPv6 at the right level, which is a real problem. IPv6 is going through 3 major, and it's about to go through a 4th major rethink, mainly based on feedback from the community. ITF does that all the time. The community is not only us as engineer and people that have to deal with it, but the vendors. So we have to be careful what the vendors add to this protocol to not open up more security issues, and I'll talk about that as we go on. So each of these right now have standards that are being moved to IPv6. The energy industry is looking for IPv6 as a way of doing better SCADA interfaces, the home and systems, the healthcare, the Bluetooth, transportation, the car shipping starting the end of the year. The high ends are going to be an IPv6 to IPv6 vehicle-to-vehicle communications. Yeah, we'll talk about that off camera if you'd like to have that discussion. So we have a lot of systems that are moving to IPv6 just to be able to stay connected. And the reason they're doing this, it's really hard to then go to the network administrator and go, can you open the firewall please bidirectionally, and then you have the policy and everything else. This at least starts the communications to say, hey, we already have an IPv6 address, what controls do you have in place for it? Look. Okay, so adoption has taken place. We had the early adoption, which was 97 when IBM started implementing IPv6 on their stack. They were the first ones. We saw early Debian having it in 2000 XP, it was in it. It could be turned on. It was turned on by default for a while. It was pretty entertaining. Linux 2.6, the current kernel is a lot more solid than it's ever been. Vista, Windows 7, Windows 8, you know, on and on and on. So IPv6 is on our devices today. Get over it. You know, by the way, if your security people haven't checked and done anything about it, there's a problem, especially if your compliance people come in. I always love this. The big question I'm asking the community right now with compliance people is, okay, did you do an assessment against IPv6? And based on your compliance, are you aware that you're supposed to validate all ports and protocols on this network and ensure they're either used or turned off? So a lot of auditors, assessors, pen testers don't even test this. A lot of organizations don't know that it's even there. So it's a big problem because we've implemented IPv6 accidentally in our environment, and our vendors are moving forward with it, but we've not really put security controls around this stuff. Oh, by the way, I just wanted to mention, so when do you think the first published IPv6 hack was happened? 2001. It was a Debian box. It had somebody popped the box, turned on 6-to-4 routing, or turned on IPv6 to 4 protocol, which is basically an encapsulated IPv6 and IPv4 and IPv6 protocol. And it was used to compromise the system, and then it was about 6 months later, another Linux box was, actually a Solaris box was compromised using exactly the same thing, a honeypot. And they were really surprised because none of the detection systems had any idea. In other words, the people in the security field don't go to IETF to make sure that their stuff works with IETF standards. They wait until compromises happen, which is really frustrating for me. In the security field for a change, now that, again, I'm a red team guy, I'm trying to beat myself. I'm trying to actually be able to not be able to get into this stuff. Okay, go ahead. So, global movement, that's supposed to be red, not black. That's supposed to be orange, and orange, and that's supposed to be green. Where the hell did that go? IPv4 is out. Basically, the allocation addresses from IANA are out. We pretty much have Asia, Europe, South America went out very quickly, which is interesting. The reason is corporations in this country couldn't get any more IPv4 addresses, so they had addresses they paid for and had addresses moved from South America. Otherwise, we would have been out of IPv4 addresses today in the US. So essentially, it allowed us to extend to March 2015. The interesting part about this is based on the last 3 continents. We typically have a standard drop as far as the usage or the allocation of it. Usually within about 3 months before it comes to the end, everybody puts in their requests and empties it out very quickly. We're expecting that around Christmas, so we're expecting not to have, before the new year, we're expecting no more IPv4 addresses. What does that mean? If you're going to put a service up, you will have to go dual stack, or you'll have to go through proxies, or you'll have to go through everything else. We're going to talk about some of the real big problems with that as we go down. Okay, so for the IPv6, I think we're good time-wise for the address. I mean, we have, I'm not going to be around. I don't know anybody that's going to be around yet, so I think we're good about that. So, momentum. Wow, your fonts display differently than mine.
Yes, because you're using proprietary fonts.
Using Apple fonts. These are actually the open source ones. That's weird. So, like IPv4, it went through the 70s, it went through the 80s, and then in 1991 it became commercial. It was opened up to the general population, and all hell broke loose. Yes. So the official day was June 6th, 2012, when IPv6 was opened up. We had a working protocol, we had working systems. We saw a lot of support from a lot of different companies to move to this, mostly because from a business perspective, they suddenly recognized their customers' ISPs aren't getting IPv4 addresses anymore. Therefore, to maintain business, they had to start moving to IPv6. As you probably saw, LinkedIn made the announcement. Facebook is IPv6 internally, and they just opened their IPv6 only environment externally recently, so that's a big deal. Amazon is using IPv6 internally, but not exposing it out to the world, so a lot of organizations are doing it. So instead of the acceleration that we expected, we're seeing faster acceleration. This curve is actually recalculated every time I do slides, and this has actually gotten worse based on the amount of people using it right now. Today, worldwide, we have 4.5% of users going to Google with IPv6. In the United States, we have almost 9% of users using IPv6 today. Yeah.
Could it be because of mobile devices?
Yep. Wow, recycling, yes. T-Mobile decided, we'll go into the details as we go further. T-Mobile decided it was cheaper to go with a single IPv6 environment and put a application on their phones to convert IPv4 to IPv6, and then on their end, any IPv4 only would terminate to that and go out to the IPv4 environment. They had major success. Their users are actually seeing anywhere from a 10 to 20% better performance on their phones. They're seeing, because NAT Live uses power, they're seeing that they have longer life on their batteries. So there's all these real big benefits for the mobile devices right now. Verizon's done it, Comcast has done it for their stuff. So we have a lot of these guys are early adopters. How about the U.S. government? What percentage do you think that U.S. government's using it externally? Over 50%. Over 50% right now have IPv6 websites, and they're moving into the email and everything else, which is taking a while. So we're seeing some real movement a lot faster than we expected. We're expecting that we get to 50% sometime within the next 2 years to 3 years. Again, I've used many calculations, and this was actually one of the worst. So we're expecting.
Why is it worse to be converting faster?
No, the actual calculation, everybody thinks I'm too optimistic. I mean, I've been doing this for 14 years, and I've been hearing me talk about IPv6 and go, oh, you're too optimistic about it. But no, we're seeing faster adoption than we expected. So there's opportunities there.
How does this affect me?
Pardon?
How does this affect me on the home network?
We're going to actually talk about, there's a whole section about that.
I don't know if you're going to talk about this one, but on adoption rates from a routing perspective,
yes,
IPv4 routes crossing 512,000.
We're going to talk about that too, and
okay.
yeah, I basically, I've been teaching classes in this space. I actually have 3 weeks worth of classes, which includes basic IPv6, a security, one for software developers. I'm developing one for SOC migration to IPv6, because apparently the security operations centers of most organizations don't know anything about IPv6, and that's kind of a problem if they're monitoring the bad guys on networks. So yeah, so this is pulling in new stuff.
3 weeks is online class?
But no, not yet, not yet. I am going between writing my classes and preparing them, and also doing whatever. They've been face-to-face up to this point. And my hacking and defending was asked not to teach it again after 2008, but I just updated it, and now I'm probably going to open it up to the general population in January. And it's fairly, okay, it is really evil. So it's good. But people pay well for that, right?
Who asked you to stop?
Okay, so I'm sorry, 9.47 just in the U.S. based on stats. right now from Google. That's pretty significant. So what's the big deal about? Okay, well, in the V4 world, we had 32-bit devices, right? It was a lot simpler to use 32-bit framing for this. The only problem with it is this octet varies between 20 and 60 octets going across the network. Therefore, there's a lot more processing that's required for the router. One of the IPv6's mantras is smart endpoint, dumb router. Okay? Whereas in the old days, it was smart router, dumb device, because we didn't have really powerful devices at one point. So we're seeing that. We're actually seeing a struggle. We'll talk about the struggle and what the implication is to you guys managing systems. So a couple things. We have the same fields, source destination. We have that version, you know. Protocol 41, by the way, is IPv6 protocol number. And we as programmers and folks in this field, we count from zeros. That would make it 42. So this must be the meaning of life, right? Yeah. We also have flow labels. Let's see, yeah, okay. So we have flow labels. We have, we need to keep a lot of this. This is where the majority of the processing was taking place on the router. This was great for middle boxes, and this has basically been great because there's papers out there and tools specifically to use these to compromise networks and to hide from IDSs and things like that. So it was kind of a lesson learned. We ended up changed some movement around things, and we also have some new fields. We have a flow label. Instead of class, the traffic class, which is meant for the routers and switches, diff serve and such, we created a field specifically for flow label. You know what that's for? That's for a host to define the type of traffic it's sending so it can be classified, which is pretty cool if you think about it. It now has a second, based on a new RFC that just dropped, is that if the field is not used, then load balancers can use this field. So this is pretty cool. So we have some options that we didn't have before. With payload length, we have next header, and we're going to talk about that. We have hop limit, and then really big source and really big destination. Again, this is only 40 octets. The header, it's always 40 octets. It's fast to process by routers, switches, hosts, embedded systems if they've upgraded their Ethernet cards. There you go. Next. So a little bit of detail. IPv4, IPv6, ICMP. What was ICMP used for? Yeah, primarily. Routing and stuff like that. Yeah, it was used for routing. We've actually changed the role of ICMP. We've recognized we needed to separate the layer 2 from the layer 3 to make it less. So if we have to move, change ARP out, or if we have to change in the lower end of protocols, that we could do that. So we separated the two, and now IPv6 becomes really important because it's used on local link for ICMP. It's used for informational for multicast and such, and it's also used to ensure that the end-to-end is taken care of. In the IPv4 domain, the routers in between chose how to fragment things. Okay, I don't know how you guys feel, but I don't like people mucking with my packets. In between, this is great for changing packets, man-in-the-middle attacks, without being able to detect it. IPv6, we have specific features that look like at things like we can get destination unreachables, which are really good. Packet too big. So essentially, we can negotiate the size of the MTU across the network. This is really cool if you have a backup network that you can use the IPv6 large frames, which is 4 gig packets. I can move all my BitTorrents in one packet. No, I'm just kidding. So reality is that we can do that, and we can all still have off network, off segment communications, part of this ICMP packet protocol. This is kind of cool, so we can actually optimize our local segments now for performance between systems. Let's see, we have lots of parameters here, but again, it was not used from a troubleshooting standpoint. Have you ever sent an ICMP packet out and it just comes up with nothing? Okay, part of the IPv6 protocol is this data field is stuffed with what the error message is. So this is really useful for troubleshooting. Okay, there you go. So I can't see any of my notes. Okay, so what we have is, we have, again, the IPv6 packet. This is called extension headers. Once we decided that we wanted to go with a standard framing for 64-bit and for the packets themselves, we decided that one of the things we had problems with is adding additional features to packets. Okay, and with the end-to-end capability, the extension headers allowed us to randomly add things that were important for your environment. Okay, so as an example, wouldn't it be cool if, there we go, as part of your processing, that you could encapsulate IPsec within IPsec. In other words, somebody trusted could terminate to my firewall through one authentication system and then terminate to another firewall or to a host directly. Could be pretty useful, right? Because now you have additional levels of authentication, encryption, whatever the method is that we can use. We can also do things like there's classifiers within the routing header that we can classify the security level of certain types of packets when they're internal to our network. So we can tell the router if I receive that this is top secret, no, it can't go out this interface. Okay, so there's lots of really cool features with these extension headers. And the way they work is we have this nice little next header option, and it points to what the protocol is right here. And then, there we go, this is without it. This is with it. So it basically points to the next header, and then it allows you to then add a feature, and then add another feature, and add another feature, and eventually get to the protocol itself. So it gives us a lot more control from an application standpoint than we've ever had before. It's both good and bad. Specific vendors have implemented it very poorly in some cases. There's actually a host identification protocol that's used with HIPS. I'm not sure if you know the HIPS protocol specifically for identifying all devices and separating IP and host name away from identifier. It's host-based, not list, which is router-based. There's lots of really cool features to it. So at this point, you're going, okay, it's getting boring. Give me some more good stuff. There you go. Okay, so difference. 128 bits versus 32 bits. We're hexadecimal versus decimal, and yes, you got to live with 1 or 2 colons versus a period. So if you see something being represented with 1 or 2 colons, there's a good chance it's not a MAC address if it's that long. We have representation of 4 numbers, essentially in 8 groups. We have lots of names for it. Chunks, it depends on where in the world you are. So it's pretty funny. Quad octet, Quex is basically one of the new ones that people are floating around, so it's easier to know, and also you're cool because you know that word, which is pretty funny. This is what an IPv6 address looks like, and we'll go into the details. Yes, I can use hex to spell all kind of fun things. Okay, Facebook actually has, yeah, I know, whatever. It was 2 a.m. I was rewriting all my slides. I'm trying to update all my material to the new RFC stuff. By the way, I'll be teaching a 4-hour class at HackDC from a consumer side, how to get on the net and everything you need to know to get your Hurricane Electric Guru certifications. That's basically, it's a hand-on. I give you some virtualizations, and you go and you do this whole action. So it's pretty cool. Okay, types of addresses. Okay, we have good old unicast, had that. V6 removed. Broadcast, there's a bunch of stuff in the press today and the last week about why broadcast is good versus not good, and router vendors that thought broadcast still existed in IPv6 and causing problems. Pretty funny. We support multicast, but right now the multicast address space is so friggin' large that if you decide to do this video on a multicast, if our ISP supported it, literally you would have one data stream going out like you do right now. You wouldn't have to have any service provider at all, and all you do is just send a URL and say, hey, check this out. So it changes the model as far as peer-to-peer, which is pretty interesting. And we also have an Anycast. We also have the concept of scoping. We eventually added link local to IPv4 when we can't get an address, so we can communicate on the local segment. Has anybody found that really useful? Okay, I didn't see any hands, I figured that. IPv6 had this all along, and we'll talk about how it's implemented. We also have a global unicast address, and let's see, yeah, public address if you're connected to the internet, otherwise you don't get one. We also have a concept called unique local. In IPv4, it's RFC 1918, it's 4193. Now, the interesting part is in the IPv4, we actually muck with the packet header. It's called NAT. In IPv6, you're assigned a routable address, and you can apply those on the outside to maintain control of where you're at with a stateful firewall. So this is actually a lot better. By the way, this address space is really cool. I've heard of some well-known banks that just did some acquisitions. They use ULA internally and were able to map within a few weeks all their other acquisitions into their environment so they could gain access to all the assets on IPv6, rolled their IPv4 to IPv6, and they were connected within a month and a half as far as good connectivity. Has anybody done an acquisition and tried to connect like a couple of companies in? It's a pain in the butt, especially conflicting address space, conflicting this. It's maddening. Especially the NAT on NAT tables, because I had to run into. I worked on a company that had 12 acquisitions, and I was doing both. I was doing the architecture and the system, and the high-level system and high-level network engineering on it, and it was a mess. It took almost a year to get it fixed and tested, and finally protocols broken. It was horrible. Okay, we also have special addresses because you have to have special addresses. We have default routes. We have unspecified, it's calling, and we have loopbacks. So in your world with IPv4 only, there's no place like 127.0 to 0.1. In my world, it's no place like : 1. Okay, and I've actually been making T-shirts up. I had a woman actually come up and say, "Is that a satanic thing?" And I had somebody else. I had some really weird comments about this. Are you missing something? The T-shirt washed this off or something? Anyway, it's pretty funny. We have link local. Well, we have multicast, which is the FF. I'm not going to go into multicast. This is where we're going to actually see, and if you're doing multiple cloud services, you're doing back end. People like Google and Yahoo use these on their local segments. So they can distribute the same data to multiple systems at the same time, reducing the bandwidth on the unicast traffic. So this has some really big benefit. Unfortunately, it's beyond the scope of this class because don't have much time. We got to do this in 2 hours or an hour and a half. We also have link local. You guys probably see this already. This is the default FE80. This is built into the operating system. So if you see an F80 and you don't see another address, IPv6 address, then you at least have a link local on the system, hopefully have firewalled or done something with it. Global unicast is a 2000/3. We have 8 of these segments, and no, I don't think we're going to run out anytime soon. One of the things Vint was talking about was allocating specific segments to different planets. So, interesting discussion. Unique local, it's one space, and you just define what that address space is yourself. There's actually a randomness component to it. Again, a lot more. And then also we have this, we were supposed to be using all of our documentation by using these addresses. This is the official, IETF standard. Except people don't do that. They open up the Cisco or Juniper manual, they open up the Linux book, they open up whatever, and what do? They use whatever address they have there for their example. They save the example and everything's good, right? Well, we have so much of this right now in public books and IPv4 that we have 10/16 blocks that are polluted with this kind of traffic that we can't fix because of this. So we created a standardized way of documenting addresses. Makes it easy to control at your routers, at edges. So go ahead. This is cool. Yeah. Next. Okay, so based on the addressing, in the old days on IPv4, we had classes A, B, C. We realized that in the early days, this made it a hell of a lot easier for us to deal with networks, because the first side part was a network identifier. Somebody registered that name, that address. We knew where that was. And then we had the interface device. That's the host or whatever on that network. The smallest address space we go is a /64. If you choose to fight this, you will break things, you will break address allocation, you will break any of the routers and switch configurations that are out there. It's just not worth it. I know a cloud provider that decided that they were going to allocate /10s, which is back here, or /110s, which was back here. After a year, they went back to my suggestion, which was using this notation. So again, routing is defined this way. This is defined on one segment. And I think you have enough addresses. I think 18 billion devices on a network is probably good enough. By the way, this is really cool with cloud computing if you have, sorry about, I'll drink later for you for using that word. But if you're using virtualization, what's the biggest pain in the ass for that? I get, a /24. What if I pull up another 10 servers? What do? Crap, I can't scale. Okay, this allows me to scale within an address space that I control. Dude, there's a whole bunch of other guys in here. No flashing, okay? So this is an important concept, and this saves you a heck of a lot of problems for security, for management, and everything else.
Does the network still work the same way as an IPv6, meaning info that any device in the same segment can sort of follow along, don't need to route between them? Or
Correct. That's why this is good. It's basically if I'm on the same segment and say that I'm using, I don't know, UPnP, or if I'm using Bonjour. Apple's got this for all their Apple gear. It actually checks for Bonjour, actually ships out the link local IPv6 address. So you don't have to have a global address, say on a printer or a camera or something else that's on segment that doesn't have a global address. So you can then connect to it and start communicating with it. That's pretty cool. Okay, so you can make choices of a device getting a global address or just a local address to communicate. That's configuration.
But usually within that segment, my point was that you have a lot of chatter. You have a lot of app traffic, you have a lot of communication that is just normal business traffic. And bigger segment, the more chatter you got.
Absolutely. And that comes down to an architectural thing. We can talk about that for about 3 to 4 hours, and the philosophy and what routers and switches work and what don't, and how to configure it. And, yeah.
Beginner's question?
Yeah.
It sounds like you're saying that there's no way, no reason, nobody, nowhere, for no purpose needs to subnet the 64-bit network identifier.
Yeah, no more subnetting this.
Oh.
No more subnetting that side, which is the local host segment. This is the routable segment. We'll talk about the next one. So, go ahead.
If a unnamed ISP was giving out /32s to its customers.
Woohoo! Yeah, Hurricane Electric, I have a /32.
That wouldn't break things.
No, because that's what I'm about to go into here.
Okay.
So by not breaking this, we focus on user interfaces here. So on the host side, that's where you deal with it. When we don't have to go and get an address allocated or whatever. On the public side, we have the public topology. Sorry about staying in front of you. The public topology, and then we have whatever the site allocation is. In this case, is an example /32. That's where that address would be here. Remember I said there was a /8 allocated? Well, that's from IANA. These are the top aggregators, which is the RLRs. And then this is reserved, but it's already being used. This was the classical notion to simplify the routing tables. The problem with it is politics got involved. Some companies wanted multiple providers, which makes sense. But a lot of people in the IPv4 space got, as an example, BGP, and they only have a single router, a single ISP, so they have no real failover. So this actually helps reduce the aggregation problem. We're going to talk about that in a minute on IPv4. So it's allocated all the way down to the site. You actually decide, once you get this allocation of these addresses, you decide how your network, how your system is configured. Okay, so a /8, wouldn't that be nice, the equivalent of v4, to have a /8 internally for use? If you've got a big environment, I know some government agencies that they went with a very large space, and now they're able to say, bam, I'm here. You know what Facebook does? Their allocation? This is the rack ID. Every rack can have this many devices, because what they recognized is by having that, all the internal traffic, as they talked about, would be on segment. So they have a switch and a router at the top of every rack. On the other side, this gives them the ability, if they were able to get 55 or 1,000 more devices on this that have addressability, I can do that without changing everything in my rack. Anybody ever have to reallocate addresses in a rack? What a real pain in the butt. It's mostly policy that takes forever to happen. So they kind of learned some lessons out of this, making their life a lot easier. Next one. So we talked about the global routing side with the last two discussions. Now let's talk about the other side, on the host side. Okay, that host address for link local FE80 is allocated one of two ways. This is the first way. This is easy for management, this is whatever, but it has privacy problems. It has other concerns, okay? But it's really nice if you're doing certain work. So what we do is we take the 48-bit MAC space, and has anybody realized that the IEEE has created a 64-bit MAC range now, because we're running out of MAC addresses? Yeah, they're available on some devices now. So that actually impacts our switches and impacts the whole.
I was going to say, what's the protocol called? You can't call out anymore.
It's called 64-bit, IU64 from IEEE. This is to actually add more devices. They're realizing layer 2 because of studies are showing that we have a large percentage of devices that have exactly the same MAC address, because manufacturers found it cheaper to print out, 10,000 devices with exactly the same MAC address versus following the IEEE standard of making a minor modification and incrementing it, or providing a random address space. So we have a lot of problems with that. So what we do is we take the company ID and the manufacturer. We, in the center, so we can visually see that it's a EUI address space. We put FFFE, and you'll notice that on a lot of your laptops in Linux, you'll see this automatically. We take manufacturer, data, company, but the only change we make is the 7-bit is actually inverted to say it's globally unique versus non-globally unique. Okay, the host does this automatically. This is very handy for a lot of reasons. So this is what the address would then look like for the EUI 64.
Is that a global or local?
The FE80 is local. But when we go into data, when we go into address allocation, we'll talk about how that works, because you have lots of choices depending on how you allocate this stuff.
And that's a reserved bit for MAC addresses, is it?
Oh, this right here?
Yeah.
Oh, that bit is just part of the standard, and all the code, a lot of the code's been tested, and it does validate this. This is handy for a lot of reasons. Next. Okay, the other side is we have random address interface called privacy addresses. These allow a host to use a local algorithm to generate the last 64 bits. Okay, especially considering they're used in GUAs in applications. Isn't that cool? We can actually tie things to it, especially within our own infrastructure. There's a couple different variations. I didn't add a lot. There's actually a security consideration for this internally. Within this space right here, we have 2 ways it's done. Sir?
GUA is what, please?
That's a global unique identifier. It's usually used in application development so that we have some unique identifier for a device, an application, and a system. It's actually really handy.
The for address not identified.
Correct. The GUID, this version 3 doesn't include the IP address. It's actually hashed. And 1 and 2, it's not hashed. So you can derive it. Let's see. So we have 2 different versions. One is it just uses a random number, and we know in Linux we've had really great success on random numbers, right? So we basically use the last 64 as a random number. And again, this is the last 64 on the host side of the random number to create an FE80 address. When companies like Microsoft have used their own algorithm to generate their own last 64 address. Now there's an extension of this called send-CGA. Send-CGA is a cryptographically generated address where you can take a piece of material and validate that that user and that system is supposed to be on the network. You can validate that the device around you are authorized to be on that segment. You can use it many different ways. Okay? Upside for you guys. It works on Linux because Microsoft and Apple refuse to implement it. And you'll hear me ranting about this a lot of different places, publicly at Black Hat and DEF CON, calling them out for it. They turned around and thought this was a great idea and then patented it, which caused a big stir in ITF because you're not supposed to patent an idea that was years submitted. So that's kind of a problem. So that's a very cool security mechanism. It actually goes with the security policies that we've been trying to implement with IPv6 to break the IPv4 policies. And we'll talk about the policies in a minute. So we end up generating a random address, tagging the prefix. It becomes a temporary address. Typically on Linux, we have one address, which is the MAC address for local, and we can also use it for global, for inbound communications. We can use the privacy address for outbound communications. Why is that important? Well, if you're doing patches every day, it's coming from a different address. So if somebody pops that log, they're not going to be able to come back at you. Even if your firewall's down, they're not going to come back at you. So with V6, well, with V4, what kind of allocation do we have for assigning addresses? We have static. We have DHCP. Any other options?
Eval?
Yeah. Link local. Yeah, but we don't. This basically IPv6 provided a lot of different options based on the environment you're in. All of these have advantages and disadvantages. As an example, Slack. When Slack is configured, it's great for the Internet of Things because it can get an address in 50 to 150, 200 milliseconds. Whereas DHCP takes time and takes a server, but DHCP provides management services and other controls. But then you want the router involved sometimes and the router not involved sometimes in this communications. So we actually have the link local, which we just talked about, the EUI64 and the privacy stuff, which all devices get one address. If we manually configure it, we get two addresses. We get the link local and we get a manual address. Oh, did I tell you how many addresses can Linux handle on an interface? 128. You can go to 1,024 easily. This is really useful for other things, but this is especially for virtualization. So we have Slack where the router allocates the address. We have stateful DHCP where the DHCP does everything. We have the stateless DHCP where the router provides a trusted message to the local systems to tell it where the DHCP server is. Kind of useful. So then it gets other information like DNS and where specific servers are and such, like the classic IPv4 DHCP. And then we have combinations of these based on how you're implementing it. So essentially you can go from one address to 4 addresses. You can go more if you decide you want to do some really crazy stuff. Okay, so you have, again, a lot of options you can deal with, and these are all architectural decisions, not for the whole enterprise, or not for your house here and here, but for, as an example, your Internet of Things stuff. You may end up using stateless Slack. You may end up using stateless so you can plug things in and out for that segment. Not a big deal. Other things you may want DHCP, and again, each of those have advantages and disadvantages. Okay, now to bring it all together, we have to have DHCP. Or excuse me, DNS. So DNS has a quad record instead of a single A record. And as you can see, he used a static address. He's got 2 assigned here. It's not randomized. It's reversed. As you can see, 26 reversed right here. To actually have a pointer record, just make sure you have your pointer records in place. These are a pain. There's scripts out there, and including links to them to make it easier to manage. We'll talk about some tools that will make it easier than that to manage. You can also get this through UPnP on local segment and Bonjour. By the way, UPnP has changed the protocol to go from a local segment protocol to an enterprise protocol. Why Microsoft did it, I don't know. But now you can actually scope up a broadcast of the device that says, hey, I'm on your network, not just I'm on the segment.
UPnP can't be secured, as far as I know.
A lot of internet.
Why would I do that on enterprise? That's one.
A lot of Internet of Things vendors have moved to it. So it's, and then Apple on the other side, they have also scaled it up. So there's a IEEE standard for that, and you've just updated the standard. So be aware of that, because you have alternate naming services. If something fails, if you don't have this set up right. Next. Okay, shorthand notation. Okay, this is the boring stuff. It gets better, more exciting. So, how many people want to type every one of those for every device we have? No. Okay. So, what we've decided was, let's create a shorthand. And yes, there's an IETF standard for this. And yes, there's a lot of applications that break this, that will cause your systems to crash and everything else. Application developers that don't understand it. It's pretty damn entertaining because I get to go troubleshoot this kind of stuff regularly. So first thing we look at is we look at consecutive zeros and leading zeros. So what we do is we have 2001, we have consecutive zeros, we have some content, we have consecutive zeros. We have to choose how we're going to compress this. We can compress it one way by doing this. We can compress it the other way by using : over here. This leads to problems with applications for routing, for lots of other things, so be aware of it. It depends on the device you're using. So from a troubleshooting standpoint, if you use one of these in your configuration files, you may want to try the other one because your developer may not have made the decision of where the : needs to go. So it's pretty entertaining, but that's a hell of a lot easier to write. And by the way, did you notice that it's A52 because the second step of this is we get rid of our leading zeros here, mainly because why press another zero if possible? We can only have one pair of colons. Can't have more than one pair of colons. There's applications that are trying to use 2 pair of colons. Very entertaining. Makes my troubleshooting hilarious some days. So, yes, let's talk about security models. The IPv4 security model. At one time, we said defense in depth. We'd put up large castles and we'd be totally protected. Yeah. And actually, from a biological standpoint, this is defined in RFC 1918, by the way. My fonts are too large. But this is actually defined in RFC 1918 that we put up using that to actually separate our cells from the outside. But from a biological model, because that's actually the space I've been working in, is how you apply biological stuff to physical world or technical world. So from a biological standpoint, this is great. This is like a turtle. Take your head and you put it in your shell. Nobody can get you. Except there's a couple problems. You can't eat. Okay? Which makes management really pissed that you say, well, we're getting hacked, so we're going to turn everything awful on the internet. Nah, it's not going to work. And we can't get rid of things, you know, excretion, so that's a problem. So we can't send things out. So what we've ended up doing with this space right now in security is we put condoms around everything. Okay, we have our proxy condoms with our FireEye condoms. We put little condoms around everything. All those open ports, because we'll be protected, right? Okay, so here's the IPv4 model based on RFC 1918. Because at one point, this right here, remember 1970s Peace Man? Okay, we trust everybody. Again, been served. Hey, everybody's trustworthy. Life is good. So we trust everybody. Okay, then RFC 1918 came in, and we went, okay, we still trust everybody, but only on my segment and only in my environment. We don't trust anybody out here, right? Okay, more. Except then we start opening firewalls inbound and outbound. So now we have, I don't trust you for an inbound connection, but hell, my IT people let me go out so I can get to anything, so I trust you now. Okay, that's not a real sustainable trust model. It's actually a broken trust model. It's great if you're a red cell like myself and you want to get people to go to URLs that are bad, because then people have to buy more services to try to block me from doing that on a real-time basis and all this other stuff. So we have lots of condoms. So this is what IRC 1918 has provided us. Okay, we are totally secure, and we have our NACs because it takes some effort to get across there. And we have multiple NACs with 2 levels of NACs here. And this is real sustainable, right?
Yeah.
Okay, this is the way I feel about some of the networks I've worked on, both when I've pen tested it and done security architecture on, is they're whatever on whatever, wherever, and there's no security trust model at all. It exists. It's really depressing. Again, when I'm a red cell, I always win. I don't mind. There you go. So RC 3756. We still had to keep the trust model. Hey, peace, man. Okay, because executives wanted that. Go to the next one. We also came up with this second one, which is we only trust the router, but we trust with no devices around us. Okay, this is part of the SEN CGA. This is part of some other projects that have come out. So we have no trust about devices around us, only here. This is great for public, but this also could be very good for Internet of Things, for BYOD, for other things. Unfortunately, the vendors haven't caught up. Remember the Microsoft discussion we had with SenCGA? Yeah, it's available in Linux. It's not available on anything else. So we don't trust the outside until the router validates us, and we don't trust anybody around us. The next one, okay? So we have a third model with really crappy funds, which is we don't trust here, we don't trust the router, we don't trust the outside world. We actually have a trust chain here, which I don't have the graphics for that, sorry. In fact,
I'm trying to, there we go.
You're removing it now! I have to go backwards, right? Cool. So we actually have a trust chain, which we can actually validate that the router hasn't been used to intercept communications. I call this the ad hoc network, or the DEF CON, if you've ever been to DEF CON where everybody's hacking you all the time. Well, or maybe the Starbucks, but that's a whole other issue. This basically requires a trust chain to validate that that router exists. This is really handy in more secure environments.
Isn't that the same as just a straight TNO mentality the whole time, though?
Pardon?
Isn't that just using the same TNO mentality like you hear all the time with Bitcoin and all that?
Yeah, it's actually an extension for Bitcoin that somebody came forward for IEEE, yes. And yes, that is, I just presented, I just put together a paper with another friend on doing evil with Bitcoin, and that's actually one of the things we did, so. Why? Because I only have 1 Bitcoin, I don't have 1 million, damn it. Anyway, go ahead. So, classes of attacks that we have today. Okay, clients bypass the firewall. Okay, that's been happening for IPv4 forever, hasn't it? They'll say I'm SSH tunnels and all these other things. Well, remember we showed the timeline of all the devices that support IPv6? Well, Microsoft was kind enough to include automatic tunnels for us, including 6-4, ISO-TAP, and Teredo. Teredo is a really wonderful protocol. It basically creates a tunnel over UDP packets, over an IPv4 UDP packet. And the current model is that all the other products in the space right now, they look for the default port because hackers would never change the port, right? Okay, so anyway, this problem has been going on forever. I get a call around this model at least once a month from somebody. They say, I think somebody just dropped a tunnel on my network. Can you come and help me with it? You know, figure out where it is and go through the process. So what this is this device is on the segment. Somebody said, hey, I'm your default router. And it basically then goes through the default router, goes through that condom, outbound condom, to wherever they want to go. Okay? Again, there's the gateway. Sorry, that's the gateway. So there's gateways that are inside, and there's also gateways that are outside. We see regularly people will accidentally set up gateways with a small configuration that will collapse the data center because now it's something else as a default router. And why is that important? Oh yes, IEEE has a precedence for which protocols we go to. First we go to IPv6 as a default route and addressing, and then we go to IPv4. Okay, so this has been used for a long time. Again, the security community hasn't addressed it. Good question? So this basically becomes auto configuration. It gets out to a gateway. It then talks out to whatever. Again, we've had this problem before. I'm not sure what kind of effort. I mean, we've made some effort to try to find this. Microsoft has made it even more fun. With Windows 7 and Windows 8, they have a new tunneling protocol. It's so cool. It's IPv6 over HTTPS over IPv4. Default. Oh, yeah. Okay. Go ahead. My life is so wonderful. Go ahead. Okay. Another one. Rogue router attacks. Pretty straightforward. Goes through a switch. Somebody defines that I'm the router because he started making router announcements on local segment. He defaults it forward to the internet. Okay. Again, at ARP level, that's always happened, hasn't it? But now it's at the ICMP level at layer 3. So there's certain controls you want to put on to detect that and stop that. Okay. Next. Okay, I love this. How many people have Macs? Because they're totally secure. Okay. NACs are based on the Ether type 800. IPv6's Ethernet type is 86TD. You see a problem there? I've used this that once we compromise the system to pivot off of the machine, use IPv6 to then get around everything else, walk in the device, blah, 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 get around this. This is the dirty little secret. It's been the dirty little secret for about 8 years because I've been using this well for 8 years as the NAC community is rolled out. So, by the way, if you didn't notice, that whole checklist of stuff, I'm actually going through each of those that I committed to doing with you. So at this point, you're going, crap! Okay, I can switch. You're going, crap! I can go, you're telling me all this caution stuff, and I can go, IPv4, but we're going to side with addressing and complexity and stuff like that. Not real happy. We can go with IPv6, but I don't know where this goes. Okay, so, you know, so maybe we should stay with IPv4 until just before it goes over and we'll be saved by somebody having yet another protocol that the vendors won't support. Which, by the way, there's like 3 out there, and they're a mess to actually manage. We'll talk about one of them. So click the next one. Legacy IPv4 problems. So we talked about you mentioned the routing table. Okay, there was an injection of between 5 to 10,000 specific routes in the BGP table. We've been talking about this. This is the reason we wanted to go to IPv6 is to decrease the amount of items in the route table. routers aren't managed. The average patch time is 7 years. Okay, people don't typically patch their routers. Okay, real problem. So we've been seeing outages now for a couple years, but the injection by Verizon of these anywhere from 5 to 10, it depends on who you talk to, of routes, dropped a whole bunch of routers around the world. Pretty entertaining. They withdrew them and all the routers came back up again. Okay, so we are right on the threshold where if you're a cloud provider, or you're using within your organization, your home, to get to a cloud service that hasn't updated their routers, or your security service, or your business transactions are on something that is, they haven't updated the router, this is a big concern for me. This is one of the reasons I suggest moving to IPv6 is the IPv6 routing table is extremely small right now. And it will be for a long time based on the way it's aggregated. It's meant to optimize the aggregation. V4 is not. It's causing some problems. Security products. Security products don't do what they claim to do with IPv4. Again, that's why I got into the business to do this. Threat intelligence. Does anybody get default IP addresses to tell you to block things on your networks? Does anybody get that? Or that this is where a bad guy is, or malware, or anything else?
Mail service, I do, but
yeah, it's a bit of a problem now. The carriers, because they don't want to buy more addresses, and then some of them haven't moved IPv6 fast enough. Instead, they went to well-known vendors, and they bought these things called carrier-grade NATs.
Yeah.
Those are these big boxes that everybody shares addresses on. And we're going to talk about the details of this. But the offset of this problem is that you're sharing the same address, which means now the geolocation of where they came from and the source of an attack is not behind one NAT, it's behind 2 NATs. Have you ever tried to chase down within your organization behind 2 NATs, and just the politics of trying to get that deep is horrible? Well, the carriers have been real nice. They make sure that they don't log in this information, so that's kind of special. Your geolocation, if you're doing any geolocation work, advertising, whatever, that's gone. There's some legal issues because of, well, lots of details. A lot of applications are breaking in this field. Does anybody use Xbox? Anybody?
It's not able to go through 2 layers max, and you can play with your players.
Exactly. So, if you and I are going to run an Xbox game, and we're on the same carrier, and our ISP implemented carrier-grade NAT, we can't communicate. We have to move to IPv6 tunnels to get there. Okay, but we then have to have an endpoint that sits at Microsoft. That never bothers me. Okay, so we're seeing a lot of applications. We're seeing voice over IP between the same carrier break. We're seeing this happen. It's actually implemented in 2 ways. One is that they push an update software package to your router to say the other side has a default route for IPv6 and IPv4. And then depending on the carrier, how far they're along, they'll either encapsulate IPv6 over IPv4 or IPv4 over IPv6. It goes to one of these magic boxes. Life is good, right? So, yeah, so this is a triple face plant. Do we stay with IPv4 and somebody will save us? Do we go dual stack, but management is about 17% more operational costs right now? That's the current study. Or do we go to IPv6? So here's your choices. You can go to, this is where most of the carriers are today. Most of the carriers have chosen to wait. Their excuses is there's no security products, or there's no management products that support IPv6. There are some carriers like T-Mobile that went and they created 464 shim that goes on other phones. It's a little application. So now IPv4 is tunneled over IPv6. Whenever it has to go to an IPv4, it goes to their gateway and goes out. Because the majority of their people are now going through IPv6, they're, I think, 28% or 35% or something like that. They've increased. They didn't require it to go to carrier grade NAT at the level, at the expense of whatever. Plus, everybody's seeing better battery life because NAT Keep Alive. You know how NAT Keep Alive works. It basically sends a packet and says, I'm going to keep on communicating with this. The router gets state, and state costs electricity and costs heat. And then eventually it either times out randomly, or the user sends another packet to say, keep that connection open. Okay, well, for a standard application, like a Microsoft box, you could end up having 50 to 150 states trying to be maintained out to endpoints. And add to that, and phones and cell phones and such, by T-Mobile going to this, they've actually reduced, again, battery life, improved battery life, and reduced complexity, which is pretty cool. We also have the tunneling world. We'll go into details. We use the automatic tunnels. We have 64 ISOTAP and Merido or Terido. Merido is the version for Linux. Okay. These are good, these are cheap, they're easy, there's problems, we'll talk about that in a minute. But that basically means your IPv4 is going over, your IPv6 is going over IPv4 and back again. Oh, what are your management controls, security controls, application controls for this at this point? They kind of fall apart. This is embedded.
Got about 15 minutes left.
Okay, I'm going to go real quick then. We also have another one that goes up this way. We also have dual stack, Comcast, Verizon, and Google. We also have tunnel brokers, HE.net, 6SX, and GoGo6. Those are all great ones. Okay, next.
You can go a little, I mean, you don't have to end it on top. So.
Yeah, but I don't want any face blinds. Let's see, so native, really fast to set up. Routers typically supported low latency, better performance, fewer hops, better end-to-end connections. If you're running a service that's on the internet, you're actually seeing it upwards to a 20% better user experience getting to your services, which is pretty dramatic if you're a web service. Tunneled, it works. You have to set up and maintain it because the ISP, if you're using it at home, ISP changes your IPv4 address every once in a while. Apparently, they don't change it if you're running only IPv4, but when they're running a tunnel to IPv6, they seem to change it a lot more often, at least for my carriers that I use. There's also MTU problems because not everybody understands this protocol. They misconfigure it. Packets get lost, applications get stuck. It's pretty much a hassle. Tested, there's the application. Oh, by the way, this is better bandwidth for BitTorrent Netflix. Set up an IPv6 tunnel and go to Netflix because it supports IPv6. They don't typically have traffic analysis on this, so you can get through and get faster bandwidth, which is kind of fun. Let's see, so native IPv6 environment, by the way, tunnels go away. The majority of the IPv4 tunnels that we can use to get around security controls, they go away because they're not part of the protocol. And we actually have a customer that I worked with 6 years ago. We went to that space, an IPv6 only environment. What is malware typically written for? Yeah, we found most of the malware, almost all of it, and then we have another technique to find more. So, kind of fun. Okay, next. Okay, you have to choose, especially for a home user. Are you going to use the ISPs or are you going to use yours? Okay, the ISP has decided that, well, there's certain vendors who don't have ONTs that support IPv6. They only support IPv4. It's going to require rolling trucks to replace all the ONTs. Kind of a problem. You also have a lot of vendors who didn't buy IPv6 compatible routers. So there's millions of routers that you have to roll a truck to grandma's house to replace the router. So this was a business decision, and actually it impacted their stock. They haven't seen it yet, but we're expecting it to actually fund and become public. Here are 3 links you can go to. These 3 links will tell you what routers they support. You'll be surprised that even routers that I received from my Comcast and Verizon connections 2 years ago, only one of them works, but not fully. So kind of a problem. So a lot of them are saying, hey, we know you've rented this from us. Just go out and buy your own router now. Okay, we'll provide a modem as a connection point, and then you're there. Okay, so be aware that's a decision you have to make, and yes, I've already been through it for all 3 of my internet service providers at home. Okay, I'm a geek. Carrier grade NAT. Next. This is what carrier grade NAT looks to the internet. You have a single IP address, but you have anywhere from 100 to 10,000 users all sharing the same IP address. Okay, you're only allocated so many ports. Okay, so if I make lots of port calls and open connections, does that break applications? Yes, it does. Okay, how long do I have that address? Well, depending on the carrier, anywhere from 60 seconds to 4 minutes. So how are you going to find the bad guy? Oh yes, and I experimented with this and tested it against something and found out that I can black out an IP address that every time I get reassigned that address, I can't get out to this one place because it showed up on a blacklist that ended up in the SANS blacklist and things like this. So this is a problem if you're using, your ISP's using carrier grade NAT for your services that you have out there and also for your organizations, because if your organizations are using IPv4, somebody can black out an IP address, say your company's system, and then your help desk calls, lots of help desk calls. I can't get to so-and-so, my VPN won't work. So, yeah.
How widely is that adopted now?
All the major carriers have either moved or are implementing this year. So,
So we could expect to see services we're hosting currently break if we're using
also your consumer VPNs will start breaking. They're already breaking, but you're getting help desk calls.
VPN services, and this is why. This could be one.
This is a strong contributor. The problem with it is that unless you know that they made this business decision, whatever. There were some carriers that literally couldn't even provide an IPv4 address to businesses 4 years ago.
Are there good ways to identify whether or not they're doing this from your own home?
Yes and no. It depends on your router because they may have hidden it. So I actually am creating a whole set of tests so you can validate that. So that's the problem. This is what the infrastructure looks like. V4, V6. Your routers changed back here. Go V6 over V4, V4 over V6. It goes to these large sites. In some case, all you have is Ashburn, Chicago, and San Jose. So if Florida or Ohio start acting up, you don't know where they're coming from, which is pretty entertaining. And then they go out to the IPv4 environment. And logging, the carriers don't typically log. So go ahead. Okay, so this is really depressing, right? Let's talk about a really cool IPv6 thing. Actually, two. Well, the community has said that grandma is really not a good network administrator. Which actually sucks. Okay, she has a couple problems. That when she puts her wireless access point on and she puts her wireless printer on, she can't print to that printer all the time. She may put 2 access points on the same segment. She can't communicate in her house. You know, she has to have somebody come in and pay, you know, whoever to make all the connections, and that's too complex. So Cable Labs and ITF create something called HipNet. There's the URL if you want to download it. It's OpenWRT compatible, so you can flash your existing routers to do this. What it does is it's multiple routers that literally, when you plug it in, it negotiates arbitrarily your topology. Okay, we took 30 devices, we plugged it in, it took about 2 minutes to take 30 devices, allocate the addresses, done. We were able to connect an Ethernet to the end of the long end of the router and be able to get internet access. Very cool. It's going to be good for disasters and grandma's house. So they're going to future backup stuff. They have automatic prefix allocation, so it's real simple to set up addressing. They have sub-delegation. It supports bidirectional addresses, so these two devices know where they are. Name resolution service, really IPv6 focused, but has IPv4 and NAT involved. Pretty damn cool. I flashed it, I worked with it, very fun. So Cisco went to IETF and said, we don't have two standards, so we must have another standard. So they created something called HomeNet. Okay? It does the same thing. Here's the big advantage. If you're using multiple service providers, it load balances traffic and communications from the host. It gives the host some controls to be able to communicate out. Pretty much all the same capabilities. But again, for HomeNet, the last one, if I put a printer over here, I can still communicate with that. I can still put my, my other network over here that has things on it that I can communicate with. So this is really an important advance for IPv6 services. Again, OpenWRT. Go. So proxies. So you can still get to IPv6 services because there are IPv6 only websites now. Here's two services to do that. What I actually have for one of my segments, I have an IPv6 only segment. And Squid with T-Proxy, awesome. Transparent. I have v6, v4 on the outside. I have v6 only internally. It works great for me. I have all these new set of controls for outbound only web communications. It's worked really well for the last year for me. I have lots more to say, but I have to not be too verbose. Okay, next. Address, okay. Scanning is for newbies and the weak. Why? How long will it take to scan a /64 address if you brute force it? Okay, if you're off segment trying to brute force and you don't use any of the really cool tricks, you will literally be retired. Let's see, where's the youngest guy here? You will be retired before somebody finds all the devices on that network. Okay, a great contractor thing, maybe you can offer that to your customers, really cool. But income for a long time. Okay, actually, I got a call last year about this, and the client was on an IPv6 only internet with an IPv6 web service, and they said, oh my God, I'm seeing logs and somebody's trying to scan my network. We calculated based on the algorithms they're using and stuff how long they would take to find their services. I said, well, yeah, you're retiring in 15 years, you're good.
This is a counter that though, it makes it very easy to hide a device on a network.
Well, that's why the second part. Okay, you can use these services for people to do passive devices, and there's some tools, but they're not 100% effective. Very problematic. This is a great way to test to see your endpoint. Now, how many people use spreadsheets to manage their addressing? Put up all your hands. Yes, you've all used that. I know, I have. It drove me nuts. There are things called IP address management tools. These management tools allow you as the architect, you as the manager of the network, you as a system admin responsible for the network, to allocate the IPv6 addresses into blocks so they have context. Okay? And then if you connect it into your DNS and DHCP, you have full context over everything. Why? Because everything has to be allocated and addressed someplace if you're using the HCP, and they have to do DNS queries. And because you don't have any NAT, you have end-to-end connectivity to figure out where the network is, what the device is on that segment. Okay, this is a big savings. Infoblox is a little tiny VMware version. That's what I have at home on my lab. University of Oregon has a project called NetDot. It's free. It's GPL3 or GPL2. So it's worth it. They also have monitoring for all these segments and stuff. It's pretty cool. So you don't have to scan your network anymore. By the way, if somebody is scanning your network, what does that mean? You have an attacker on your network. You have an insider that has tools that are not authorized to have. So this becomes, it's rid of the noise. It decreases your logs. Getting tired of that. Monitoring and protection. Whoa. You really have bad funds because I don't. This is an IPv6 only neighbor discovery. It's for the local segment to look for any mucking around. It's been updated, but it's not actually complete, but it does give you some ideas of what you can use. This is a detector for some of the older tools. And good old Security Onion, it's not 100% IPv6, but it does have some services if you're using it. I'm just mentioning this from a security perspective. Next. Linux firewall. Please, 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 make sure you turn on stateful inspection in your IPv6 tables. This is a big problem. I've been fighting this with scripts for the last 6 years. I was speaking at the Ohio Linux User Group 6 years ago about this particular topic. And what was happening is people were creating scripts that you would say, hey, I'm going to use IPv6. And the IPv4 tables would be turned off, and your IPv6 tables would be turned on. So it's kind of problematic. And then they were only, they were only stateless. So this is real important. You got to go through your rules and make sure that there's complementary on both. Okay, from a protocol that is support to IPv6. So if it's HTTP, you want to put the firewall on the other side. SureWall does a good job. At least for me, it's quick, it's easy. I'm looking for easy right now that I can't break too much. A bunch of scripts right here, how to set up your stateful, a bunch of recommendations real fast. Troubleshooting your network. Tools to test. This is amazing. You guys see Analyzer? Anybody? Do we have like a minute to pull this up? You might find this interesting. Oh, you can't see my screen.
Well, I can do that.
Yeah, okay. We also have website validation. Okay, I've got a question. In the Linux community, how many vendors would show up at your door, knock on the door, and say, we're a Linux provider, but you go to their website and it's all Microsoft? Okay. Is there an integrity issue here? Is there a question that you have about that? Would you buy products from somebody that doesn't even use Linux? That one address that I had at the bottom, sorry, you got to run Java. It's bad. This is out of Berkeley. This is a test. You go down here, click on that.
Oh, I got a little bit here.
Sandbox it, yeah.
Yeah, let's just trust it all.
Wow, Grandma. So this does a really cool thing, and if you flip back to the slides, it's going to take. You don't have to finish that out. Just go to the bottom of the screen.
Well, I can't see the button on the screen, so.
Oh, okay, sorry. It's doing the lookup right now, so if you want to go back to the regular slides, and we'll come back and show you this. Thank you. I had one. Okay. For vendors that are telling you that they support IPv6 services, here's a really great URL to see if they're running IPv6 locally. So let's see. Every major of the top 100, because I just did this recently, Contractors in this area all claim they do IPv6. Guess how many have an IPv6 capability? 0. Their web service, their mail service, their DNS, they don't have it. So I was at a CIO council for the federal government. What they're doing now is they're telling all the agencies, if they're not supporting IPv6, you don't need them. They don't understand themselves from business. By the way, Facebook is doing this, LinkedIn is doing this. It's actually, in some cases, there are some military agencies that are literally saying, I don't even take a call. Claiming you have IPv6 or whatever. Yourself, once you get it up, give me a call, and then we'll chat because you're just wasting my time. Okay, so that's the attitude a lot of people are getting right now, is that if you don't have a security product that supports it, you don't even have your own interfaces use it, you're not eating your own dog food, how are you going to ever know it? And how can you trust that it supports IPv6? So, okay. Okay, yes, I'm a startup. I need some people. That's actually why I was willing to present. Really, I need somebody with cloud experience. I need a programmer, and I need UI, UX. Also, my security tools. If you want to test my security tools, I'm looking for somebody. There are people that have a no IPv6 enabled connection. I have a set of tools that are really unique. We'll talk about it offline if you'd like to see it. It gives you better threat intelligence, which is pretty cool. And then also, if they're V6 or none, we can detect all those tunnel types, and we can even detect other type of bad things that are occurring specifically in the IPv6 migration. So that's enough. I don't need to talk about it too much. So if you guys have anything, I've got a car, talk to me. Again, I'm a startup. I'm trying to kick this business off to support IPv6, and all the products in the space are good. I've been using it to get around for years. My friends are using it to get around. It's time for real good IPv6 products. So, and that's it. Any burning questions? When's IPv7 coming out?
The reason I asked about the 512K route before, when we were talking about adoption of IPv6, everyone I know in the industry is handling it by recovering their TMs to steal address space from IPv6.
Yes, I know.
I understand that
specifically people that are in the loud data center row, because I've had this discussion with a bunch of guys. I have a get-together with a lot of guys in that space from a security perspective, and they're doing it, and they're making their IPv6 stuff unstable. But yeah, they're actually running out of space. Fortunately, we're talking less than 2% of the space right now is IPv6. And not the whole world has BGP. And now because of the large allocation, if you're a company as an example, you have one route to you for that large space. Right now, most organizations have anywhere from 5 to 50 sub-addresses that they've. Yeah. So, bit of a problem. And yes, it's been discussed on NanoList, it's been discussed on IEEE, it's been discussed in the security community. We know it's a problem. Those are the business decisions they're making. We need to be aware of it as consumers of their services because it puts us at risk. Okay, the colors are so much better than the real thing. Okay, so what this does, well, it's top. Comcast. Really? Okay. So you're using Comcast, and there's the IPv4 address. It says that, oh, certain protocols are blocked. Isn't that special? Okay, and they have buffer bloat, and wow, DNS types are not processed correctly. Could be your outbound router. NAT detected, local interface detected, DNS information there. If you open up the little pluses, you get lots of really good information. You just open up that and it'll open up everyone. Shows you the randomness, which is really nice to find out if your router's messed up or You go down to that one for local interfaces. It defines all your local interfaces, so it's great for troubleshooting stuff. What interfaces are open. You're not running Tor. You're not on a blacklist. This is how you find if you're being blacklisted. Use this product real quick. Oh, look, and UPnP is not there. That's special. Okay, go down to there and open that. I like this. This is like remote control, laser control. Okay, so we have a lot allowed. We have specific block protocols. By the way, Microsoft didn't port RPC 135, 137, 139 to IPv6. They use 445 now. Notice that when we go down, if you ever get IPv6, Comcast still blocks the same ports on IPv6, although Microsoft doesn't use that protocol anymore in those ports. It's pretty fun. So this gives you an idea if somebody's doing modification of things, which is very handy. UDP, this tells you what UDP ports are open and blocked. Modified gives you a decent trace route because the trace route's from them to you. Look, bad Comcast. I like that. Path MTU, if you open that up, okay, it's open. If you're using IPv4 and IPv6, this is great to identify if one of your upstream routers has a tunnel on it, because that size will become smaller. Okay. Network. Okay, you want to open this up? This checks for buffer bloat, a whole bunch of things. Your round trips, background health, what your up and down are based on their perspective of the world. They have a gigabit connection, so I think they're faster than you. Latency, which is always good, and they are detecting buffer bloat. HTTP test, this will actually show if your IP address is blocked from a common website. And if somebody is doing transparent proxying, no. So this is great for a hotel because very quickly you can see if they're doing transparent proxying and doing man in the middle for your SSL. DNS tests, and you'll see a bunch of good things there. I can't see the colors, so I can't. Speed, go down. Okay.
One bit, this is internal server error on yeah.
Okay. Glue records are there because sometimes glue records aren't. It gives you the resolution and the Kaminsky attack for DNS. This will tell you if there's any randomness in your own DNS. Go down, down, down. IPv6 test, open that up. Nope, you don't have a IPv6 connection. By the way, if this is a consumer grade Comcast,
this is what it was.
Is this consumer grade Comcast?
No.
Okay, if this is consumer grade Comcast, just change your router out, get their bridge, change your router out, and you'll get V6 by default. Full stack. Network protocols, this is real interesting. If you have DNSSEC and you're intercepting that, and then local properties. Anyway, this is a real handy thing if you have a desktop and you're setting up IPv6 in your segments and you want to see anything about it, what's wrong, what's not wrong. It'll give you a very quick way of detecting that, which I just love that. Okay, and any other questions? Sorry.
Are there any good any recommendations for a router to buy off the shelf? Or should you buy something WRT compatible?
For myself, I have a bunch of WRTs I flashed for this other protocol for my test network. For my I can't go down because girlfriend will kick my ass network. That one I have a Azus, ASAS, or something like that. It works. It's AC compatible. It supports IPv6. It's dual stack. It has filtering you can put on it really, really well. Give me about 6 months. I was just provided a project to do testing against 50 consumer routers, so expect a really cool presentation at Black Hat.
Joe, shall I turn the light on?
Yes, please.
Yeah.
So now you've been, turn on. Can't say it without it. Okay. Go ahead, you can turn it on. Now you can be enlightened about IPv6. I'm a punny guy. You have another question?
Yeah, I ask you, is your website provide training class information?
Not yet. I'm still. My provider was GoDaddy. They claim that they do IPv6. They claim that they support dual stack DNS. Initial testing, they did. I put it up. It didn't work. So it took, it's now taken 2 weeks to finally move to Donna DNS, who does an awesome job for dual stack IPv6, IPv4. Really good job. I'm moving my server up. I've now been through 18 different cloud providers, and they claim to do IPv6.
What was the name again? Giant?
Gandhi. The guys in France?
Yeah.
Yeah, Gandhi. G-A-N-D-I.
Yeah. So what I ended up doing was I tested all these for IPv6. Amazon claims to do IPv6. They actually have a proxy in front of you to go dual stack to v4. So most of them are doing that right now. So you can't get context on a lot of v6 packets from a security or from whatever perspective. I'm going through all these providers doing the testing. It's been about 3 weeks before I can figure out where my web server needs to go. Because right now it's on my home server, and I prefer it not to be on my home IPv6 server. So, I figure I'm gonna get traffic someday, So yeah, it's probably January, February. I got to move my server first before I can actually put the video services up and then train. But if you want some, email me and I can give you some other friends that have different types of training.
Okay.
So, other questions?
Are those slides available online?
Email me and I'll send you the PDFs one. There's a bunch of notes in the note fields, which some of them are, this particular thing actually has the evil slides in it too. So, limit access to those. Any other questions?
Do you like to put gateways on the 0th address in a subnet or for the first?
Guess what? It can be any address. The 0th address and the last address are now usable. And what's really nice is Cisco recommends using the 0th address. Therefore, you can enumerate a segment by going to the 0th address to see if it exists. By the way, we've got lots of really good training that doesn't have a security perspective that's presented out there on IPv6 over the last 10 years. And some of those decisions they've made make it easier to hack into systems. Again, it makes my job easier because I can tell you who taught it based on where how they set things up. But recognize there's different security models and there's new ways of thinking about this, as you probably now have a different perspective on this. You can put it on the 0th, but then you can also do link local and it doesn't matter. So now it's not routable, it doesn't show up in your tables. But those are tricks that you can pull to make security devices disappear from your topology, which is fine. So, anything else?
You know, consumer grade BIOS has V6.
No, they don't.
What does it look like?
Are we done videotaping now?
I can start talking one time.
Yeah. Bye.